मैं स्टार्ट कर देता हूँ। मैं आपको होस्ट बना रहा
Okay, good. Thank you.
हूँ। आप होस्ट हैं।
Okay, good. Thank you.
ओके, गुड लक
Uh,
गाइस।
yeah. Okay. Now you can leave if you want. Okay. Let me call Javed. He may not be able to see the new link. Hold on a minute.
अस्सलामुअलैकुम।
वालेकुम अस्सलाम।
Javed, you can start. I think you have to leave in a half an hour.
So let me share the screen. ये स्क्रीन शेयर भी डिसेबल है। सरोज भाई आप म्यूट पे है, तो ये स्क्रीन शेयरिंग भी डिसेबल है।
Let me see. Go to participant recording, start share. Um, mm, let me see how I can make a host to you. Anybody can see that how, because everybody is the host right now, right? Except Javed. So do you see that how we can share it? Can we give him access?
क्रॉस इंजीनियरिंग के साथ मेरी जूम की अच्छी
I
ट्रेनिंग
make
हो
a
रही
host.
है।
Now you can try. Now you can try.
Okay, now I can do that. मैं कह रहा हूँ मेरी जूम की अच्छी ट्रेनिंग हो गई है कॉस्ट इंजीनियरिंग से ज्यादा।
Oh, yes.
Okay, so far just a quick review in 2-3 minutes और फिर मैं न्यू टॉपिक्स पे जाऊंगा. uh, we covered the material that includes the raw material and purchase parts, standard buyout components of the shelf, जिसे हम कहते हैं कि हम जो जाके मार्केट से we can buy it. और some of the components you need to manufacture, develop, like पहले डिजाइन होगा, कॉन्सेप्ट डेवलप होगा, डिजाइन होगा, फिर उसका प्रोटोटाइप होगा, फिर मैन्युफैक्चरिंग होगी. सो वो जो मटेरियल होता है वो रॉ मटेरियल में आता है. देन वी कवर्ड द डायरेक्ट लेबर. डायरेक्ट लेबर वो जो वर्क स्टेशन पे डायरेक्टली इन्वॉल्व होता है. फिर उसके फ्रिंजेस बेनिफिट लाइक वेकेशंस, हेल्थ केयर एंड रिटायरमेंट कंट्रीब्यूशन फ्रॉम द कंपनी. तो वो फ्रिंजेस या बेनिफिट्स में आते हैं. एंड देन इनडायरेक्ट सपोर्ट के वो डायरेक्ट लेबर और मशीन के बिटवीन जो रॉ मटेरियल है या जो कंपोनेंट्स है वो वर्क स्टेशन तक कैरी करना, लाइक फ्रॉम वेयर हाउस टू ब्रिंग इट टू द वर्क स्टेशन. So ये टॉपिक we covered so far. So the new topic is burden rate, and the burden rate is itself, like you consider, this is, so far we covered 50, let's say 40%. The burden rate itself is the 50% topic. Like इसमें multiple portion है. So can you see my Excel screen?
Yes.
So the burden rate में मल्टीपल फैक्टर्स होते हैं, लेकिन आई विल कवर ओनली major cost contributors, and then I will explain later the other minor factors. Like one is capital. कोई भी मशीन होगी उसकी कोई कैपिटल कॉस्ट होगी कि उसको हम बाय करेंगे. लाइक एनी मशीन, even if you are using your bike or your car, that we will call that machine. Then उस मशीन, बाइक या कार को, आई ट्राई टू गिव यू एग्जांपल विच यू कैन थिंक अबाउट. लाइक कार है या बाइक है, उसको रन करने के लिए आपको गैस या पेट्रोल चाहिए होगा. तो इस कुछ मोस्टली मशीन्स वी रन ऑन द इलेक्ट्रिसिटी. उसमें समटाइम्स वाटर भी रिक्वायर्ड होता है, नेचुरल गैस रिक्वायर्ड होती है. सो द मेजर सोर्स इज लाइक इलेक्ट्रिसिटी और नेचुरल गैस, क्योंकि पेट्रोल का ऑप्शन इज एक्सपेंसिव. बट आई एम गिविंग यू एन एग्जांपल ऑफ द कार. सो ऑल ऑफ दीज सोर्सेज हम यूटिलिटी में काउंट करेंगे. देन कोई भी मशीन होगी, उसको हम जब प्लांट पे इंस्टॉल करेंगे, सो वी सो स्पेस कॉस्ट विल बी रिक्वायर्ड होगी. कार होगी, कार को हम जगह जगह पार्क कर देते हैं पाकिस्तान में, बट लाइक इन नॉर्मल कंडीशन कंसीडर दैट वो आपका एक स्पेस लेती है. घर में भी अगर आप उसको पार्किंग है, वो एक स्पेस आपका लेगी. तो इसी तरह मशीन को भी हम प्लांट में इंस्टॉल करेंगे तो वो कुछ एरिया कवर करती है. तो उस स्पेस कॉस्ट को भी हमें कंसीडर करना पड़ेगा. एंड देन वन मोर फैक्टर, यूटिलिटी हो गया, स्पेस कॉस्ट हो गया. देन मशीन को रन करने के लिए कुछ मटेरियल्स होते हैं जो कि ओनली 1% पार्ट ऑफ द ओवरऑल कॉस्ट, वो इनडायरेक्ट मटेरियल होता है. इनडायरेक्ट मटेरियल इज बेसिकली मशीन को रन करने के लिए आप ग्रीस या ऑयल या कुछ ऐसे मटेरियल यूज करते हैं जो मशीन को रन करने के लिए आपको काइंड ऑफ पार्टली मेंटेनेंस में आता है। फिर मशीन में जो आउटेज होती है, ब्रेक डाउन होता है, या कुछ कंपोनेंट्स ऐसे होते हैं कि यू नीड ईयरली या एवरी 6 मंथ्स या इन 2 इयर्स एक मेंटेनेंस रिक्वायर्ड होती है। तो वो मेंटेनेंस के लिए आपको वर्कफोर्स और कुछ इक्विपमेंट चाहिए होते हैं। सो बेसिकली there are other factors too, but I don't want to go to that level. I will explain it when we will discuss about those factors. लेकिन फिलहाल ये 5 फैक्टर्स आपके बर्डन रेट को डेवलप करते हैं। बर्डन रेट इज बेसिकली कोई भी मशीन है, उस पे कितनी कॉस्ट आई, कितनी यूटिलिटी आपने कंज्यूम की, देन हाउ मच स्पेस दैट मशीन ऑक्यूपाइज, then indirect material to run that machine. We use that indirect material, and then maintenance. So I will cover first the capital cost, yeah, investment. So किसी भी मशीन को हम बाय करेंगे तो लेट्स से कि इंजेक्शन मोल्डिंग मशीन है, इट हैज डिफरेंट साइजेस लाइक tonnages. के tonnages is kind of like say force. So depending on the part, you will have small plastic parts, even your cell phone cover, या फिर जो गाड़ी में आप कार में आप देखते हैं कि उसका फ्रंट एरिया जिसको हम बम्पर कहते हैं, किसी ज़माने में वो मेटालिक पार्ट होता था, लेकिन अब वो प्लास्टिक पार्ट होता है। इसी तरह आप जिसको डैशबोर्ड या ग्लव बॉक्स कहते हैं, that is also plastic parts. कार में इफ़ यू इमेजिन सो मेनी प्लास्टिक पार्ट्स, सो हर पार्ट्स के लिए डिफरेंट टनेजेस की मशीन चाहिए होती है, और जो भी मशीन डिफरेंट मल्टीपल टनेजेस अगर आप कंसीडर करते हैं तो उसकी इन्वेस्टमेंट अलग अलग होगी। सो हमें बेसिकली जब पार्ट प्रोड्यूस करते हैं तो वी हैव टू काउंट दैट अमाउंट, लाइक यू हैव टू बी लाइक one machine makes so many parts for so many models, multiple components के लिए। हमें ये चाहिए कि लेट्स से कि एक टीचर है आपका एनईडी में, वो, या आप मुझे काउंट कर लें कि आई एम टीचिंग यू। अब अगर मुझे अपनी कॉस्ट मालूम करनी है कि मैं आपको टीच करने के लिए मेरी कॉस्ट कितनी है, तो उसको मैं कैसे कैलकुलेट करूंगा? तो मैं ये कहूँगा कि मेरी ईयरली सैलरी इतनी है, उस ईयरली सैलरी में मैं आप लोगों को सिर्फ लेट्स से एट अ टाइम हाफ आवर या 1 आवर मैं कंज्यूम करता हूँ, या मैं आपका जो असाइन है, तो उस 1 आवर की अगर मुझे वैल्यू मालूम करनी है, तो मैं, यानी कि ये एक एग्जांपल मैं दे रहा हूँ, तो इसी तरह एक मशीन है, उसमें मैं लेट्स से के 1 मिलियन स्पेंड करता हूँ, उसकी इन्वेस्टमेंट हो गई 1 मिलियन। 1 मिलियन मीन्स 10 लाख, 10 टाइम्स मल्टीप्लाई बाय 100,000, 1 लाख, सो 1 मिलियन। अब उस मशीन की एक लाइफ होगी जिसको हम डेप्रिसिएशन में काउंट करते हैं कि ये मशीन हम इतने साल तक कंज्यूम करेंगे। तो सॉरी, लेट मी एक्सप्लेन फर्स्ट द, तो जब आप मशीन बाय करेंगे, उसको आप प्लांट में इंस्टॉल करेंगे, सो वो एक इंस्टॉलेशन कॉस्ट होगी उसकी। लाइक आपने सप्लायर से जो भी मशीन मैन्युफैक्चरर होगा, वो मशीन लेट से कि if that is in one city and your plant is in other city or other country, so वो जो मशीन होगी वो वहां से शिप होगी, देन आफ्टर शिप, सो आप शिपिंग कॉस्ट लेंगे, उसकी ड्यूटीज लेंगे, एंड देन यू विल इंस्टॉल इनटू इनटू द प्लांट। सो ये सब कॉस्ट आएगी इंस्टॉलेशन में. अब इंस्टॉलेशन इट्स डिफरेंट फॉर एवरी मशीन, लेकिन अगेन दिस इज द परसेंटेज फैक्टर, द इंस्टॉलेशन. सो overall we consider 10% of the overall investment is the installation cost, and in that cost shipping, transportation, and then installation cost in the plant. So अगर मैं 10% इसका लेता हूँ इन्वेस्टमेंट का, तो 100,000 इज माई इंस्टॉलेशन कॉस्ट. लेकिन सिंस के हम कॉस्टिंग कर रहे हैं, हमें कुछ मेजर फैक्टर्स एंड माइनर फैक्टर्स वी हैव टू कंसीडर बोथ, लाइक मेजर फैक्टर्स एंड माइनर फैक्टर्स. सो we are like after 10 years, even injection molding machine and stamping machines you can run for 30 years or 40 years, but the company rules is like we will consider that every 10 years we will buy you a new machine to supplier. So let's consider this machine for 10 years. लेकिन after 10 years हम we can ask suppliers that if you consider new machine, then what you gonna do to old machine. So most of the time in US we just put the garbage things outside our home. इसी तरह कुछ कंपनीज जो ओल्ड मशीन्स होती है उसको सेल कर देती हैं टू द लाइक some of the suppliers they make components for multiple use. पाकिस्तान में क्या होता है कि वो बूसी टुकड़े वाला या सम ठेले वाला आता है, उसको यू give your product and you get some money. So that is called scrap cost. So you recover some money from that scrap. So you have two choices. One is you scrap, or one you used to give it to other company. If you will give it to other company, you will recover more cost. But we consider the residual, we call it residual value. I believe that is the right term. So we consider that whatever is the investment, we will get 5% of the residual cost. So that will make 50,000. So my net investment or net investment will be, I will take this amount, the investment plus installation, and what I am going to do with the residual value. Gohar and Maria, could you please explain? I will add the residual value or I will minus the residual value. So this residual value 50,000, I will add in my net investment, or I will minus or I will minus from the net investment. Like I added the installation. So what I am going to do for the residual value, I will add it or minus it. Addition or subtraction.
Subtraction.
Gohar, please, your response. You're on mute.
Um,
Yeah.
I think correct.
And why we will subtract?
I I'm not sure. The receivable value means like the remaining value of the product.
And Maria,
Yeah.
your response. You are on mute.
सब्ट्रैक्ट करेंगे हम क्योंकि हमें वो कॉस्ट मिल रही है.
Yes, exactly. Uh, so we are going to get that number. So our overall investment will be 1.0 1.05 मिलियन। अब हमें 1.05 मिलियंस को एक लिमिटेड टाइम में ब्रेक करना है कि so that we can apply, like, if you remember during our practices we used to calculate dollar per hour, that this machine will cost this much dollar per hour, or that many dollar per minute, or that many dollar per second. So इसके लिए एक एक्सरसाइज हमें करनी पड़ेगी, हमें कैलकुलेट करना पड़ेगा नंबर ऑफ डेज। Okay, before number of days, let me explain one thing, that since we are using this machine or depreciating this machine for 10 years, so depreciation or machine life, let's say machine life, 10 years. So per year, अगर मैं कहूँ machine life 10 years है, so machine cost investment per year क्या हुई मेरी? Please go ahead and explain me, like, what from this data, what will be my next step? How I
Net
am going to
investment will be my net investment will be divided by machine life.
how about you, Gaur? Is it right or wrong?
Yes, I agree. That what you do now.
So ये मेरी मशीन की नेट लाइक इन्वेस्टमेंट पर ईयर आ गई।
Yeah.
1 मिलियन था, ओनली 105,000 हो गई। अब मुझे इस पर ईयर को आवर्स में और मिनट में कैलकुलेट करना है। सो फॉर दैट आई विल कंसीडर नंबर ऑफ डेज पर ईयर कितने हैं आपके? थ्री 365, जिसमें वीकेंड्स में जो अमेरिकन रूल है, we don't count Saturday or Sunday. So basically, पर ईयर 52 वीक्स होते हैं, जिसमें 365 डेज होते हैं ऑलमोस्ट। अब वीकेंड्स क्या है? सैटरडे एंड संडे, 2 डेज, जिसमें हम काम नहीं करते। मशीन भी, इवन suppliers, they can run those machines on Saturday and Sunday, but in accounting or calculating burden date, we don't count that amount. So how many days I am going to minus? 52 weeks and then multiply by 2, Saturday, Sunday. 104 days we are not working. Then each country, they have holidays, like July 4th Independence Day or 14th August in Pakistan, or Christmas, December 25, 26, we don't work. Qaid Azam Day, December 25. January 1st, we don't work. Eid, we work in America but not work in Pakistan. So I'm just calculating these days, like those are approximately 15 or 16 days. Let me put 15 days. So let's say if I have to calculate so far productive days, where we can work. Total 365. What I'm going to do with the weekends? I will plus or minus.
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 And how about the holidays? Plus or minus?
Minus.
So total I have 246 days. Basically, we have here 16, like holidays, and these are variable according to the country. If I have to calculate this for Pakistan, I will take only one day in weekends because Saturday normally they work. So, but European country and America, I will take 2 days. So these two numbers, weekends and holidays, are variables. It will go according to the country. In some countries, it will be maybe 30 days. Some countries, it will be maybe 10 days or 5 days. Then there is a plant shutdown where we do the maintenance. So those are basically for 1 week. This is routine maintenance, like we do the entire plant shutdown. If something goes wrong with the machines, we also consider that, but this is the routine numbers. So I will take that out. So these are my productive days. So if I have to calculate investment per year in investment per day, what will be my next step? I cannot hear anyone.
ईयर्स को मल्टीप्लाई कर देंगे डेज से और डिवाइड कर देंगे इन्वेस्टमेंट से.
Like so far we are till column G. So what I am going to do with the available data, like for column H, what I am going to do?
The investment per year divided by the amount of data productive days.
Yes.
So my investment per day is $437. Now I have to do it in hours. So hour wise, we have how many hours a day we have?
24 minus, well,
No. Like I will not go. How many hours we have in a day? Like
24.
yes. Now out of 24 hours, every supplier they offer 30 minutes lunch and 2 breaks after 2 hours. So per shift, you get lunch for 30 minutes, 0.5 hour, and 2 breaks 20 minute. So 20 minute by, it is 10 minute per break divided by 60.4. And this is shift wise. So 24 hours a day. Sorry, I should have go.
Make it 15 minutes.
The breaks.
Yeah. So in this way, 1 hour out of 8 hours.
No. Like there are other factors too. Like that 15 minutes. It is different for each supplier, but
Okay.
I'm taking like considering 4 or 5 companies that count. There are other factors too. Like I did not take it out all of them. So we have 3 shifts basically. If you will consider Sarvat by Ford, it will be 2 shifts. Like the Ford calculation method is like 2 shift, 10 hours each shift. But the supplier side, they run 3 shifts, 8 hours each. So shift means one group will work 8 hours and then they will go home. Then the second group will come, they will work 8 hours, and the third group. So in general, we have, it could be 2 shifts or 3 shifts. But for accounting purpose, and it depends, if it is 2 shifts, we will calculate according to the 2 shifts. If it is 3 shifts, we will go according to the 3 shifts. So agar 3 shifts hai isme, so what we gonna do? We will divide the number with 3 shifts. If it will be 2 shifts, then we will divide by 2. But then not necessarily that each shift will be 12 hours. We'll have to define that. And I don't want to complicate at this moment right now. So let's consider we are running 3 shifts. Now, this lunch and 2 breaks, I am considering per shift. Then some machine maintenance hours, we leave it. So basically, the rule of thumb, if you count me, if you have to count, you take 8 hours, multiply by 85% efficiency. So 6.8 hours per shift will be productive. So out of 8 hours, we have already taken out 0.9 hours. So let's put maintenance or outages. And these are unexpected. The routine maintenance we already considered here, plant shutdown. But these are like, it could be, maybe you will get no maintenance or outages, or maybe you will get per day 8 hours. But this is average of the per year. So if I have to count this per shift, my productive hours 6.8, right? So per day, this is per shift 6.8. So per day it will be 6.8 multiplied by 3. So if per day I am spending 437, per hour I will take 6.8 multiplied by 3. So 1 million machine, which will cost us 105,000 per year, if I have to use that machine, it will cost me $21 per hour. And if I have to go further, Okay, what I am going to do now? I will divide by
60.
what is that?
60.
Maria,
60.
if I divide by 3600, uh, uh, what will be my investment per? Let's say if I divide 3600, so that will be investment per minute or investment per something else.
Second. Second.
Okay. So now if you recall that we did
जाओ
exercise,
ना ना बैठ
we
जाओ
did we did exercise for burden rate per minute or per hour. So that's how we came with those numbers. And now again, this is only investment. We have to consider utility, we have to consider space cost, we have to consider indirect material and maintenance. So individually, we will calculate all of those factors and then we will add, and that will give us the burden rate per hour. So I just covered only one factor today, investment, which is normally 50 or 60% of my burden rate. Like let's say if my burden rate is $2, so 40 or 50% of the cost or 60% of the cost will be investment. And then 40% out of 40%, maybe 30% will be utility, and then remaining factors will be 10%. So we will calculate one by one uh, in our each session. So any question, concern, that is my, the
Um,
topic.
for the investment per hour, why do you divide by 3? Because, mm,
So
the-
investment per hour, we calculated investment per day. So per day, if I have to consider how many productive hours I have, so per shift we calculated 6.8 hours, but that is per shift. It's not end of the day. End of the day will be 3 shifts. So per shift, my productive hours 6.8 hours, and to calculate per day, I have to multiply that 6.8 hours by 3. Like my productive hours per day,
okay.
so 20.4 hours.
Mm,
We take 19 hours at 19.5 or 19 hours at Ford, and this is debatable item, as I said, like depending, and that will be kind of next level. So just keep it to 20.4 hours. In some companies it will be 20 hours, maybe 19 hours, 19.5 hours. But here excuse me. So for now, just take 20.4 is my productive hours. As I said, it could vary, minus half hour, minus 1 hour, or minus 1.4 hours. But for now, just take it. Any other question? Or Sarwat bhai, if I miss any item?
No, you covered very well. Mm, only thing is that I want to give them a little bit assignment, you know, convert this one, both of you separate, and consider weekends, the holidays separate, and the plant shutdown days is going to be a little bit different. So, and then maybe Javed or I will ask the question how it works. Your breaks will not be 20 minutes, your break will be 15 minutes. So, can you make it both separate assignments for the next week? So, the reason I want to give appointment assignment Javed because I want to make sure they understand everything very well.
Yeah, last 1 or 2 times, especially last time, you're right. I could not send them that sheet. I should have sent that one, and I'm going to send for both the last week activity, the direct labor, indirect labor, and this practice as well, because otherwise it's easy to forget the item.
Right. And remember that instead of 3 shifts, you will be considering 2 shifts. Lunchtime
Yeah.
will be half an hour, and the breaks will be 15 minutes, 2 breaks of it. And consider whatever the Pakistan holidays are, 'cause the weekends are the same in Pakistan, right? So then calculate. These are the 3 factors you have to reconsider that one, and that let's see what will be. And then we will ask the question once you make a model. Should be very simple.
Okay.
I'm not. I didn't understand you. You're saying that we should use make a model with the
Let me repeat again one more time.
yeah.
Consider instead of 3 shifts, consider 2 shifts. Write it down. Lunchtime will be half an hour.
Okay.
Instead of 2 breaks of 20 minutes, gonna be a 15 minutes break.
Mm-hmm.
All other
Okay, let's do this, Sarwat bhai. It will be easy for them. So you have to consider 2 shifts. This one.
10 hours each.
I don't want to use these formulas, so I will take it out. This one, this
Yeah,
one.
remove the.
So 2 shifts, 10 hours, and lunch is half hour, but the breaks are 15 minutes. So this 0.4 hours are based on 10 minutes, so you have to calculate that. So all this data, you can use it, and maintenance or outages, let's put this 0.5. And weekends, let's use one day only. And holidays, let's use uh, uh, 20. And let's use plant shutdown 10 days. So you can develop with this data some manipulation. Also, investment will be 2 million. Installation will be 15%. I use 10% here. And residual value 7%. I use 5% over here. You will develop all of these numbers based on this data. You can make a picture, or
Yeah, take a picture of that one in case of if you forget to send it because you have to go, right. So take a picture if both of you, Gohar and Maria Beta.
Okay. So Sarwat bhai, I'm pretty much done.
Yeah, you can leave. You can leave.
Okay.
Okay, thank you. Now let me share that. Did you take the picture?
Yes.
Okay. Oh my God, why I cannot. Wait a minute. I have to allow myself to share the screen. 1 second. Maria, can you make me a co-host? My other Sarwat?
जी सर मैं करती हूँ,
हाँ,
ट्राई
मुझे
करती
co-host बना दे दूसरे Sarwat को.
हूँ।
Then I can share.
सर यहाँ पे ऑप्शन आ नहीं रहा है, मैंने मोबाइल से ज्वाइन किया हुआ है तो इसमें ऑप्शन आ नहीं रहा है।
Yeah, that is the problem is happening with me too. Unable to access for the best. Yeah, same thing is coming with me. Somehow it is not allowing me to give me access or making a co-host. I think maybe the same numbers or let me try in this way. It is important to so you can see the go to setting. Uh, One participant can share at a time. Only one participant is showing. Oh, now I can see that, right?
यस सर मैंने आपको होस्ट बना दिया।
Oh, very good, very good. Okay. Now you can see my screen, right?
Yes.
So, any question about about the packaging? Both of you, if you do not have any questions, remember this website. And we will be doing again, very simple thing. I mean, I'm not trying to make it very difficult. Always pick you up for the Wikipedia or in this way you can easily see that, right? So remember, all these ones are the one. Just remember, but the keywords. If you remember the keywords, you'll be able to get it all these packages, right? And you don't have to remember all these packages. See that these are the simple packages, right? Not difficult packages. These are about less than 200 packages in there. So these are the one which are the key packages you have to remember in your when you do the real life. That's including the passive and active, all of them. So before that, we used to have a books and all that stuff and everything. But now life is very easy. I just go there, look at this package, look at this size, and then you can calculate based on that. The real experience when will come, try to capture, one printed circuit board from anywhere, right? Any old computer, any printed circuit board. I mean, try to get it this one. So in this way, you can really can see that. If you have the old uh, cell phone, that will work too. Any old computer which you want to discard, you can open it up and use this printed circuit board, because I can show you a lot of printed circuit boards, but the most important is that you can look at in your real life. I mean, real way. Any of your friend has old computer which he's not using, he wants to throw away, take it out the PCB from there, or any old cell phone, which you have it, just open it up and just use that printed circuit board. Okay. So if you do not have any question, we will go there. We will talk about the next thing. We'll talk about the PCB. You see, remember that we talk about this PCB. This PCB, these are the one which is traces are going. These are the different traces. I will go one by one with the PCBs. You can see my screen very well, right?
Yeah.
So, so again, same thing. You just type printed circuit board wiki, right? And this will come up. Printed circuit board, and this will come up. So you will see that this is the printed circuit board, and you can see that these are the printed circuit boards. And there are many things are in there. I will go one by one with this one. Basically, printed circuit boards are made of different layers, right? One is a conductive layer, which is, you can see that normally it's a copper, and you can see that where the electricity runs. Conductive is the one where you run the electricity. And the insulation is the one, insulation, right? Where you cannot run the simple layman terms, you cannot run the electricity. You can run as the electron on it, right? That is the very simple definition of it. The basic thing is that this printed circuit board has a lot of number of layers. The number of layers and thickness, we will talk about this one later on. How much is the thickness, we will discuss, but these are normally about 2 layers, 4 layers, 6 layers. So basically, you have a one conductive, which is a copper, and then another insulation where you, and then another copper. If there's a 2 layers of copper and 3 layers of insulation, which we also in the common terms we also use the pre-pack. So if we use those one, then it's called a 2-layer boards, where you have 2 layers. If you have 4 layers of copper in between them, then it's got a 4 layers. If there is a 6 layers, normally they are not come in they are come in the even numbers. So they do not come in the odd numbers, either 2, 4, 6, 8, and the thickness we'll talk about that one later on. So, and you can see that this is a copper, and this is insulation. And also in this one, how you can connect one copper layer to another copper layer. You want to run the electricity, right? You want to run electricity from one layer to another layer. How you gonna run? Because all this one has a lot of traces. See these dark, let me make it bigger. Okay. So what was happen when we make a layers? This is, you can see maybe only just the top layer, right? These are the one which is copper. You can see very well, or you want me to zoom it more? So these are the, I assume you can see very well, right? Remember that we talk about the
Yes, sir, it's
LQFPs?
clear.
Yes. Remember that we talk about that uh, all these LQFPs. These are the LQFPs. These are the resistors, and these are the capacitors. And these are the one. What was happened? You put a one layer of the copper. You are any one of you are familiar with the etching process? If not, no, don't worry about it. There is a one flat um, copper sheet is attached, right? I told you that one layer of copper and one layer of insulation or a pre-peg, and then another copper, another pre-peg, right? But you don't want to run this whole thing, yeah? So on the top layer, the one which is just below the pre-peg, there is a copper layer. And wherever they needed the connection, they just remove all other copper. You see that here is no copper. Here is no copper. And this copper is going. So what etching process does, they remove the copper where it's not required, where it's not connected. So basically, this is the one which is the etching process, right? Basically, this dark, you see that these dark lines are going on now. These are the coppers. These are the coppers. So basically, basically all this was like a dark copper, but we removed the copper, from from uh, here, and between the lines. You see that the light darker one, that means there is no copper on it. Any question until now? So each layer has this kind of a, maybe it's a little bit different than this. Maybe they are connecting, some other, whatever the lines are going. Basically, these are the copper lines are going on, the dark ones. These are the dark ones, or the copper lines are going on. So any question? I know it's going to be a little bit tough, but it is important to learn all this stuff. Any question? And the copper is the one where it runs the electricity, basically in layman terms. Any question? If you do not understand, ask me. I will explain in better words. So everybody understand that, these copper lines are going on. Basically, these are the one where it runs the electricity. Okay. I will open one more. See, let's take the example. And these, you see that there are when we are using the word uh, see the same lines, these are the copper lines. You see that this is the one which is running from, you remember that I talk about this one. These are one pin, right? One pin, second pin, third pin. These are the pin in a bigger. You see that? Basically, this pin is attached with this SOIC. See, this one is attached with this another component. Basically, this one trace is going, trace is the one basically a copper, right? So this trace is going and is connecting here and is connecting with this resistor. And that is also connecting from here to here too. So there is a purpose of these lines because they want to run the electricity on those lines. Okay, so number of layers. See, everything is in there. When we type just printed circuit board, they will give you a lot of information. And you remember that apprentice is a layer which most always arrange in the pairs. See, I told you it's in the even numbers 2, 4, 6, 8. Interconnected design between the vias and PTH. Vias ke through hold karte hain. I will show you the vias too. Basically, the vias you can see here too. You see that a small piece is a via. This is a via. This is a vias. There are different, vias, kind of a vias. I will come to the vias later on. But these are the vias. Let me show you in a bigger picture. These are the vias. See, now you can see better. These are the vias. This is the vias. These are the vias. These are the one which is interconnecting to each other. So, number of layers. Go back to the number of layers. You remember that I talk about there is a one layer routing option and better control of signal integrity, but are also consuming costly to manufacture like section vias for the board. One of the simpler boards is the two layer. You remember that I talk about that one two layer. Both sides of that are referred to the external layers. Additional copper layer and insulation. So after two layers is only two layers, right? For 4 layers, there is a 4 layers of that. Ground planes, you already know about what is the ground plane. Multi-layer, the board material laminated together, lamination. See, remember that we talk about that one. The sandwiches. Sandwiches means like one layer of the copper, one layer of the insulation. And each plane copper is etched. You remember that this comes with a plain sheet of the copper, right? But when the etching, only where we need a copper, where we run the electricity, that is the only one with it there. Only outer layers to be coated, surface finish, we call that surface finish. I'll talk about that one later on. You remember that we talk about that through hole technology, which is going through the board. This is an example. This is a through hole. This is a SMT. Through hole component mounting. See, this is a very good picture of it. See, here the component is going. Oh my God, how are you? This picture. here, right? You see that these are the one which is going. This is a PCB, and it is going through in there. This is the it's very good picture to see that how is the printed through hole. Okay. Any question? I know it's very dry, but once we complete this one, then I will make it try to make it a little bit more interesting thing, right? When Javed explained you, that's why I want to keep it both together, right? We want to keep it both together. So with your a lot of interest where you can keep the interest, the Javed can give you the very simple way of calculation, how the system work, how they do the calculation and everything. And this is a very dry stuff, I know, but that is the way you have to learn. Once you learn everything very well, uh, it will be very valuable information for you. And we will talk about the different type of components. We will talk about little bit more definition. I'll make it very layman terms of definition for all those components. That is also coming. But until now, any question on a PCB? It is very important to ask any question now. Etching process. See, this is the etching process. They put in a yes, yeah. Go ahead, beta.
What is etching process?
Etching process where you do not. There is a plain sheet of copper is come, right? Plain sheet of copper, right? But you want to make a layers on these coppers. See, this is all this copper is all this black, completely black. But we remove all this area of copper. Remove this area. We don't need this copper. So when this copper is removed, only we need just line of these coppers, right? So rest of the copper, this is a plain sheet. So we remove all this copper from there, and we use just use this one. Only this we need only just one thin line, another thin line, another thin line. That's the way it's etching process where we remove the copper. See here also good example, right? This is the copper is going. Here we remove all the copper. Here we remove all the copper. Here we remove all the copper. And only we need this copper lines. Actually, it's complete. All this one is complete one sheet of copper. Clear or more question?
Yes, sir, clear.
Okay. For the proper definition and all that stuff, they have a they have a big clunch of these copper. They put it in the chemical bath, and whatever their copper is needed, rest of the copper is removed. So they remove all the unnecessary copper. The proper definition is here, but I give you very simple way of this one. See, this is a very good example of this one. See, wherever you need the copper, I think they remove the copper, here, 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 and only keep the copper here. This is just a very generic example. Okay. Okay. The next thing is that electronic component. We already talked about that one. Through all, we will go a lot of more details about these components later on and the definition of these components. And you see that this is a very good stuff. See, This is a very good example. See, you see that how they are connected? These are the wires are going on. These are the wires are going on. This is a very big picture. It looks thick, but they barely can see with the ball eye. I mean, these are very, very thin. Sometimes you won't be able to see that. See, these are the copper. These are the lines are connected with the outside. We talk about that one, and then soldering. Okay, soldering is the process. Welding, right? You're familiar. You seen that the welding ever?
Yes,
Answer.
sir.
Okay. So basically, a welding is like very strong joint. I'm giving you very simple words, right? Uh, Welding is a very solid joint. Solder is not as solid as, but that is very easy to work with them. We do not require a very solid joint on it, right? So we make it very simple joint, which with the two hands you can remove those coppers. Those are not very solid. So basically, in a proper definition, is a filler metal surfaces are heat melted and बड़े आराम से ना 179 you can melt it in about 179 degree, right? Versus welding, you require much higher temperature. And within seconds it's automatically becomes solid. Okay. Any other question? So this printed circuit board kahan se aaya? You remember that we used to have a DVD player,
Yes, sir.
old back days, right? Nowadays everything you are streaming guys, right? But DVD player में से इन्होंने they brought this printed circuit board. And let's talk about now thickness of that one. We are good in time, or I think over there it's already 11 o'clock, right? You want to spend few minutes more, or you think we should finish it?
Few minutes is fine. But यहाँ पर अभी जोर time.
Okay. Yeah, so let's do it 6 minutes more,
Okay,
because I think you have to go to the university next morning. So we will be done in about 6 minutes.
okay, fine.
So you remember that I talk about that copper. So each layer, one layer, second layer, these are the thicknesses. The more current you need, more thickness is required. In an industry word, it's called 1 ounce copper, 2 ounce copper, 3 ounce copper. And 1 ounce copper, this is also a very simple thing. If you put in the Google, just put a Google and just put thickness of PCB, right? It will come up, no problem. Or you can put thickness of copper in a PCB, Wikipedia, right? It will all this information will come. So basically, in a copper, there is each layer depend upon. Okay, sometimes it's 1 ounce copper is the one which is low grade temperature, like 5 volt, 10 volts, 15 volt, 20 volt. But if you have a component which is like 700 volt or 800 volt, right? At that time, you need much more thicker. अगर आप आपने देखा है ना कि घर में कभी कभी शादी का वक्त आता है तो आप जो है ना वो थोड़ा सा मोटा वायर लगा लेते हैं। आपके चाचा, नाना, फूफा, जो भी आपके दोस्त रिश्तेदार जो भी होंगे, वो थिकर मोटा वायर लगा लेते हैं ताकि उसमें से ज्यादा, क्योंकि आपको शादी के वक्त ना कुछ ज्यादा इलेक्ट्रिसिटी चाहिए होती है, ज्यादा आपको घर की सारी लाइटें जलेंगी और ये होगा और सामने टेंट भी लगा हुआ है, और सो यू नीड अ लॉट ऑफ मोर इलेक्ट्रिसिटी, राइट? तो वो जो पतला कॉपर जायर होता है, जो बाहर से आप ग्रिड से आप जो इलेक्ट्रिसिटी ले रहे होते हैं, तो अगर पतला वाला टायर होगा ना तो वो बार बार ट्रिप होगा और इलेक्ट्रिसिटी चली जाएगी, तो मोटा वायर लगा देते हैं, तो उससे ज्यादा इलेक्ट्रिसिटी जाती है। सेम कॉन्सेप्ट है यार। सो so basically 1 ounce copper is 35 micrometer. Micro is 10 raised to the power. Answer my question. What is micro? 10 raised to the power minus? Go ahead.
6 minus 6.
Minus 6. Correct. Okay. Um, so basically, this is, imagine that 10 raised to the power minus 6. So the thickness of this one is 0.00006 meter. Very, very thin layer of copper is, it's called 1 ounce copper. When we have a component which is we are using for higher voltage, you use 2 layers, 3 layers, 4 layers, up to 7 layers. I know up to 7 layers, but the cost is not increased. 1 or 2 layer ki cost may be double. Two going 1 to 3 layer, maybe triple. But when you go more and more thicker, then the cost is increase a lot, because to make it this PCB, it is a very difficult process after 3 ounce of copper. And substrate on core, which is already explained. Pre-peg is the one I was talking about. This is the most common term used, which we are using as insulation, right? So I was telling you the pre-peg, right? It's a common word in the industry, is a pre-peg. That is basically resin impregnated fiberglass used to glue a multi-layer PCB together. वही बस एक कॉपर की लेयर आएगी, एक प्री-पैक की, एक कॉपर आएगी, एक प्री-पैक की आएगी. We will talk about the surface finish and solder mask later on, and the legends we are writing on this one later on. Any question? We have only 1 minute left.
No.
So we will continue again with the same thing. I'm saving all these for you. We'll talk about the PCB. We're gonna continue about the PCB again next week, and we'll talk about little more detail about this copper thickness. Okay, beta. Okay, and thank you very much.
Okay.
And inshallah, I'll talk to you in a couple of weeks.
All right. Thank you.
Thank you.
Yeah, man.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.